Ever wondered what separates a top-tier doomsday bunker from a glorified basement? It's not just about thick concrete walls. Today, we're diving deep, ranking bunker designs from the ones that would fail at the first sign of trouble to the truly impregnable fortresses. We'll explore everything from catastrophic blast valve failures to genius bulletproof power systems. This is the ultimate guide to what makes a bunker work, or what makes it a tomb. Let's start at the bottom of our list with the weakest link, the DIY Backyard Special. Now, I love a good DIY project, but when it comes to surviving an apocalypse, a buried shipping container just won't cut it. The biggest problem? Structural integrity. These containers are designed to be stacked, not buried. The immense pressure from the surrounding earth can easily cause the walls to buckle and collapse. Plus, waterproofing is a nightmare. Without a professional concrete encasement, you're basically building yourself a leaky underground coffin. And let's not even get started on ventilation. A simple pipe to the surface, that's an open invitation for contaminants, radiation, and anything else you're trying to hide from. So the DIY container bunker gets a solid F. It's more of a hazard than a haven. Moving up the ladder, we have the converted Cold War-era fallout shelter. These can be found all over, often under old public buildings or even private homes. On the surface, they seem like a great option. They were built for a purpose, right? Well, yes, but that purpose was surviving the initial fallout from a nuclear blast in the 1950s and 60s. The standards back then were different. The concrete might be thick, but it's often degraded over time. The biggest point of failure in these older shelters is the mechanical systems. Original ventilation systems are likely rusted out, filters are long expired, and the hand-crank generators? Good luck finding parts for those. Many had inadequate sanitation, leading to a quick decline in hygiene and a massive risk of disease. While better than a shipping container, a retrofitted Cold War shelter requires a massive investment to bring it up to modern standards. It's a decent starting point, but without a full gut and rebuild of its core systems, it's a risky bet. Now we're getting into the serious contenders, professionally installed prefabricated steel bunkers. These are what most people picture when they think of a modern bunker. Companies specialize in building these cylindrical or rectangular steel shells off-site, delivering them and burying them for you. The quality here can vary wildly, but a good one is a huge step up. They're engineered to withstand soil pressure, properly waterproofed, and often come with pre-installed plumbing and electrical conduits. The key here is the installation. A rushed or improper installation can compromise the entire structure. But the real weak point we see time and again is the entry point. A standard hatch, even a heavy steel one, can be a vulnerability. More importantly, it's the blast valves. A cheap or improperly installed blast valve on your air intake and exhaust can fail under pressure, rendering your fancy air filtration system useless and your shelter compromised. A high-quality prefab gets a B-, but only if you pay close attention to the details, especially those crucial valves. Let's talk about the A tier, the custom-built, reinforced concrete monolith. This isn't a prefab unit. This is a fortress engineered and built on site. We're talking rebar-laced concrete walls, several feet thick, designed to withstand immense pressure and impact. The key advantage here is total customization. You can design the layout, the depth, and most importantly, integrate all systems seamlessly from the ground up. This is where we see truly robust systems. Think multiple redundant air filtration systems with oversized blast valves that are shielded and built into the concrete structure itself. The entrance is no longer just a hatch, but a multi-stage airlock system with blast doors that would make a bank vault jealous. Sanitation is handled by sophisticated septic systems, and water comes from deep protected wells. The main challenge? The astronomical cost and the time it takes to build. You also need highly specialized engineers and contractors. This is a fortress for the truly prepared, and it earns a solid A for its sheer toughness. So, what could possibly be better? What sits at the pinnacle of bunker design? Welcome to the S tier, the fully self-sufficient, geologically integrated deep earth shelter. This goes beyond just being a structure. It's an ecosystem. These are often built into the side of a mountain or deep underground in stable bedrock, using the natural geology as the primary layer of protection. We're talking hundreds of feet of solid rock between you and the surface. But the real game changer is the power system. Forget a simple diesel generator that will eventually run out of fuel. These bunkers feature bulletproof long-term power solutions. We're talking geothermal energy, tapping into the Earth's own heat for power and hot water. We're talking underground micro-hydro systems if there's a water source. We're talking redundant solar arrays on the surface, heavily camouflaged and protected, feeding massive battery banks deep below. The life support systems are equally advanced, with CO2 scrubbers, oxygen generators, and even underground hydroponic farms to provide a sustainable food source indefinitely. These aren't just shelters, they're subterranean habitats designed for multi-generational survival. They feature redundant systems for every critical function, from water purification to air circulation. This level of design anticipates not just the initial disaster, but the long-term challenges of living in a changed world. It's the absolute gold standard in survival. So there you have it, from the downright dangerous to the virtually invincible. It's clear that a bunker's strength isn't just in its walls, but in its lungs and its heart, the ventilation and power systems. A failure in a tiny valve, or a reliance on a single finite fuel source, can turn a multi-million-dollar fortress into a trap. True security comes from smart design, redundancy, and thinking not just about surviving the blast, but living for the years that follow. Which design do you think is the most practical? Let me know in the comments below. Thanks for watching, and don't forget to like and subscribe for more deep dives into the world of survival. Stay safe out there,